So this is question number 10 of homework 5. The demand curve and the supply curve for 1-year discount bonds with a face value of $1,020 are represented by the following equations. The demand curve B superscript D is price equals negative 0.7 quantity plus 1,140. The reason we have a negative sign here is because demand curve is downward sloping. And the supply curve B superscript S is price equals quantity plus 720. And here we have a positive coefficient. Here is 1 before quantity because the supply curve is upward sloping. So the first part of this question is, what is the expected equilibrium quantity of bonds? So basically, this is the two linear equation system. We can solve out this system pretty easily. How can we do that? Why don't we just write down this equation? So we have this. Let me just use price to denote the price here, and that equals negative 0.7 times, let me use Q to denote quantity, capital Q, and so that's, and then plus 1,140. So this is my demand curve. And then my supply curve, price equals Q plus 720. And to solve out this, because you have two unknowns, so the first step you want to do is to get rid of one unknown. So how can you get rid of one unknown? Notice that the first, on the left-hand side of the equations, on both the demand and the supply curves, both have P. So now if you subtract the demand curve on both sides from the supply curve on both sides, then P disappears. And then you are only left with an equation with Q. Then you can solve out that one unknown equation. And once you solve out that Q, then you can plug in either demand or supply curve to get this P. So that's the strategy here. So as we said, the first step is to get rid of this P by subtracting the demand curve from the supply curve. So then the left-hand side, because it's P minus P, that becomes 0. And then that equals, so this is the demand curve, the supply curve minus the demand curve. So you have Q minus negative 0.7 Q. So minus a negative sign, negative number becomes plus a positive number. So that's Q plus 0.7 Q. And then when you combine terms, that becomes 1.7 Q. And then plus 720 minus 1,140. So that, let me write down one more step. Just give you more details. 1,140. So now you can move these two numbers to the other side. And then exchange the sides. So you become 1.7 Q. Move that to the left. And exchange sides once you move this to the other side. And remember, when you move a number to the other side, you have to change the sign. So this negative 1,140 becomes positive, and this positive here becomes negative. So you wind up with 1,140 minus 720. So that gives me, you can use your calculator, or because this number here is very straightforward to do, so I can just do it in my mind. So that's 420 basically. So then how can you get this we can just continue that. When then we solve out Q by dividing both sides by this 1.7. So Q equals 420 over 1.7. So that the final step, I can just use my calculator. Let me erase all these numbers here. So that 420 minus 1.7. 247 point, we have to notice the requirement, the rounding requirement. Round your response to the nearest whole dollar. We don't have to use round any decimal places. So that gives me 247. 247. So, and why don't I write down this number here too? 247. So let me check first part of this. Check my answer. We're done. Continue. The expected equilibrium price of bonds is, as we said, once you get the quantity, you can just plug in that quantity into either the demand or supply. It doesn't matter. It will give you the same answer for the price. So why don't I just plug in that number into the supply curve, because it looks like the supply curve is a bit simpler. You can directly plug in Q and plus that plus 720 and get that P. So once you do that, you get this P equals 247 Q plus 720. So that gives me, again, because it's very simple, so you can just do that calculation, either use your calculator or just in your mind. So that gives me 967. Let me check my answer. 967. Again, yeah, I didn't read the rounding requirement, which is a bad habit. So you should round the response to the nearest whole dollar. So that's also true for the bond price. Sometimes it may have different rounding requirements, even though it's rare. But just to be on the safe side, you need to read the rounding requirements for each number carefully. The expected interest rate in this market is. So once we know the price of the bonds, and because this is a discount bonds, the discount bonds means that it's zero coupon. So you buy the bond at a price which is lower than its face value. The face value is given to be $1,020, and the price we just calculated, that's 967. So you buy the bond at the price 967, and once the bond matures, and the bond has a 1-year maturity, and you will be returned $1,020. So from those two numbers, you can calculate your return, and that return basically is your interest rate. And also for the reason that this is a 1-year bond. And otherwise, you have to factor into the number of time periods. Here, actually, it's very simple, so you don't have to do that 1-year discount bonds. So you buy that at this price. So the return here will be given by the interest rate. So that's R. That's 1040. That's how much you get when the bond returns. Sorry, it's 1020 minus this price 967. So that's basically your capital gain, and then divided by the initial investment. That's your 967. So that gives you the return, which is the interest rate here. So put those numbers into your calculator. 1020 minus 967 over 967. So that gives me 5.48%. So I have to note the rounding requirement. Round your response to the 2 decimal places. You see that here it asks you to round to two decimal places, no longer the nearest whole number. That's why I said we need to be super careful. So the final answer here is 5.48%. 5.48%. Okay,